Good afternoon. Thank you for having me and for coming. It's a pleasure to be part of this ECS meeting, given the progressiveness with which ECS is really advancing openness in alignment with their mission. The Center for Open Science is a spin-out from my laboratory at the University of Virginia with a mission to increase openness, integrity, and reproducibility of research. And we do that in a variety of ways I'll review, but at the core, our mission is to align values and practices. What are the values of scientific research, and how are we doing our science every day? And can we shift the culture so that we increase the likelihood that the values that we come into science to do, what we think will advance and accelerate science most readily, are the things that are incentivized and part of daily practice. So we can start in thinking about what are those core values of science. And Robert Merton, the sociologist of science in the 1940s and 50s, tried to articulate what are the norms of science, the things that characterize science as a body of process and knowledge compared to other ways of knowing things or doing things. And one, he identified communality, the open sharing of information. Right? Scientific claims don't become credible by asserting them via authority. They become credible by showing the basis of that claim. How is it that I arrived there? What were the data that I generated? How did I analyze those data? What interpretation did I draw? Being able to see that entire process prior to the claim is the means with which scientific credibility is established, compared to secrecy. Nope, just trust me, it's all fine. Right? Another is universalism. Scientific claims are evaluated based on their own merit. The research itself is the basis for deciding whether it's a credible claim or not, versus the counter norm of evaluating research by the reputation of the researcher. Oh, well, they know what they're talking about, so I'm just going to trust it. Another norm Merton identified is disinterestedness. The researcher is motivated by knowledge and discovery, just trying to figure out the truth, versus self-interestedness, trying to get ahead of the people down the hall, treating science like a competition. Right. Fourth norm is organized skepticism. A researcher considers all new evidence, even that against prior findings or work that they have done, versus the counter norm of organized dogmatism. I spend my career after I defend my dissertation, publish that signature result, and then fight off all the people that said that I was wrong for the rest of my career. And while Merton didn't describe it, another common norm of science is the notion of focus on quality versus quantity. Now, these may be recognizable norms. An interesting question that Anderson and her colleagues wondered is, do people endorse them? When we asked scientists, 3,300 or so, NIH awardees in this case, they asked, which of these do you endorse? The norms that I showed you on the left or the counter norms that I showed you on the right? And this is a cumulative plot of the survey responses of early career, which are people in postdoctoral positions, mid-career are people who are in their first R01 award. So at NIH, that's the average age of around 40 at the time. What you're seeing here in the gray is about 90% of researchers are saying that they endorse the norms of science over the counter norms. Whereas in black are those that endorse the counter norms over the norms. Very, very few people said that they believe that the counter norms are the way that science should work. And there were some, not very many, that said that they're equal weighting between the two. So then Anderson and her colleagues said, okay, don't tell me what you endorse, tell me how you behave in the research that you do. And it looks like this. Right, so about 60% of early career and mid-career researchers are saying that they behave according to the norms of science. They're open about their process, their findings, and otherwise. They're skeptical of their own work, et cetera. Still very, very few are saying that they behave according to the counter norms of science over the norms. So they said, okay, don't tell me what you do. Tell me what the other people in your field, what do they do? Look like this. So there is a very strong perception that while I, as a researcher, believe in the norms of science, I try to behave according to the norms of science, that is not the standard practice in my field. That's not what's endorsed. That's not part of the culture of how science operates. How science operates is in self-interest. It's competitive. There aren't as many jobs as there are people, and so I need to do things to advance my career. And what's a career advancement in science? The currency of science is publication. I need to publish as frequently as I can in the most prestigious outlets that I can. And whether the basis of that claim is openly accessible to others is not relevant for publication. Whether the science itself is accurate and credible is not relevant necessarily for actually getting it published. The publication is the end result rather than the impact of that result following forward, given the way that the incentives are structured. And so the fact that researchers themselves embrace those norms of science but perceive that the culture is not reinforcing them, that we are creating an incentive structure that induces us to do things that are counter to what we actually value in science, creates a challenging gap. It creates a culture where we have to actually make a decision. Do I want to behave according to my values, be open and transparent and try to be reproducible in all the work that I do, but then disadvantage myself in career advancement because others are not doing that and accelerating their career? Or do I give up on my values and embrace the fact that I need to do these things in order to survive in career and not produce as open or reproducible science? So this is the challenge, the gap that we seek to address and help with all of the lots of communities that are working on this issue across scholarly domains. And ultimately, we think that the core issue is a very simple one. It's really to address something that we learned in kindergarten about how one does things well. And it's just two simple things: show your work and share. If we accomplish just those two things, science will be better off, both for aligning the values that we have in research with our daily practice and in accelerating the impact and the accuracy and the credibility of the work that we do for others. So we engage in this in three different ways when we think about openness. One, open access, already well discussed, the focus on the outcomes. What is it that we found in this research? Can we make sure that is more accessible? Open data is also a maturing discussion, recognizing that just the fact that the paper is available doesn't mean that the findings themselves are reproducible, for example, or couldn't be challenged or thought about or reused or extended in different ways. And so having the data available is a means with which we can establish reproducibility of findings and potentially aggregate and reuse data for other uses that weren't in the original paper. The third that is of great interest to us as well is the workflow, the process by which I arrived at those claims, that how I generated that data, how I analyzed and interpret that data for publication, for interpretation, for others to see. And a key part of the focus on this is that the incentives are so strong to report positive results, to report clean results in order to maximize my likelihood of publication and to maximize the prestige of the outlet in which I publish, that opening the workflow creates an opportunity to foster incentives for not just transparency of how I'm making my claims, but the entire process by which that work is generated. So to accomplish this, we contribute in three different ways to the many groups in the community that are working on these issues. The main activity, we have a staff of about 55, and 2/3 of the team builds all free open source software to make it easy for researchers to open the outcomes, content, and process of their research. We have training services so that people know how to enact open, and we work with a lot of other training groups on that. And then we are working with all of the different stakeholders in the research community across research silos to try to nudge the incentives so that what are the core values of science are aligned with what's in my interest as a researcher. So just one example of some of the incentives, and then I want to spend time on the technologies that we can use to help support the research you do. One, Ashley mentioned the top guidelines, is a collection of standards of what is it to be open and definition of those standards that a collaborative, diverse group came together and defined these, sort of aggregating a number of different guidelines from different sources. And these are standards that can be adopted by journals or funders or institutions to create as a framework. How is it that we are going to promote openness within our research community, among our grantees, among our authors? And so authors or journals or societies or other organizations become signatories to the top guidelines and adopt them in transforming their policies and practices. There's more than 5,000 journals now that are part of the top guidelines. ECS is one of the organizational signatories. And each of those standards has different levels, because we recognize as a broad scholarly community that different areas of research are at different places in how it is they think about a number of these standards for openness. So I just want to show you data sharing, for example, of these multiple levels that give flexibility to communities to adopt based on what's appropriate in their circumstance. A level 1 adoption of the data sharing standard requires that the article, if it's a journal adopting it, that the article states whether the data are available, and if so, where to access them. So it's a disclosure standard. You just have to say whether data are available or not. If a journal, in this case, adopts level 2, then it's a data sharing requirement. Data must be posted to a trusted repository, and exceptions, because of commercialization, intellectual property, privacy issues, they must be identified at article submission so that the editor can decide, is this a reasonable exception, and grant that at that time to still consider the paper. Level 3 is not just requirement, but verification. So the data must be posted to a trusted repository, and the reported analyses in the paper will be reproduced prior to publication to show that they are in fact reproducible. These data generate those findings. So each of those standards has multiple levels so that journals or societies or institutions can adopt based on what's appropriate in their circumstance. And so this is a way to align the incentives across the different stakeholder communities. Funders can't continue to impact the research past the funding period of a particular grant. But if they align their policies on top with journal policies on top, then the journals become the mechanism of enforcement, as it were, for the original grant policies that required open data sharing at the outset. So there are a number of other incentives. I just wanted to highlight that one. The technology that we try to do to support researchers in making more of their, not just their content and outcomes available, but their process available as well, is called the Open Science Framework. This is a free project management infrastructure, all open source, where individual researchers can create accounts and then then in their account create projects privately, add collaborators to those projects, and then use that service to manage the data, the materials, how it is that they're doing the research as they do it. The central parts of the Open Science Framework as a project management and then as a data archive are to try to address some of the practical challenges that researchers face when they're considering the fact that the incentives aren't aligned for them to be practicing openly. So how can we get researchers to engage in practices that will improve openness and reproducibility if the culture doesn't yet support those universally? Well, the key there is to solve problems that researchers have now rather than so that they get value out of the service given their existing workflows. So one barrier for researchers to be more open and reproducible is that they're not organized to share. So the OSF provides those project management services so that internal to the lab itself, there are mechanisms to be more effective and efficient in lab management. My laboratory has people coming in and out of it all the time. Different grad students and postdocs are coming in and going out. Each of them, before we had the OSF, had their own ad hoc systems for managing their materials, their data, their lab books, whatever it was. And once someone left, a lot of knowledge and access to information went with that person. So OSF provides a cloud-based solution to facilitate that project management so that as soon as I'm tagged on a project, I always have access to that project. We don't rely on memories and effective alignment of different practices. A second barrier for researchers to sharing is that they just don't have time. It is a competitive marketplace. There's a lot of projects happening. And what happens in most cases for data sharing is that it's appended to the workflow. It's an extra thing that I have to do after I've already gotten the reward that I wanted, which is achieving publication of that article. Now I don't want to think about that project anymore. I want to move on to the other projects and not have to try to revisit and do something that's a lot extra. So OSF tries to support the entire research life cycle so that as you're working with that data, as you're preparing it for doing your own analysis, it is simultaneously preparing it for making it easier to share in the future so that you don't have an additional step at the point in time where you're ready to share. And then the final point is that we're not all ready to share at the same time. We have a lot of projects where the data is private for a variety of different reasons and needs to be private for some period of time. There are some labs that we work with that have these massive data sets that they use for multiple different publications, and they want to reserve at least some of it for a longer period of time rather than releasing the entire data set right at the outset. So the OSF provides flexibility so that researchers can maintain privacy of any part of their research that they want to maintain privacy, and only open the components that they're ready to open, when they're ready to open them. And so by doing that, we can integrate the private workflow of laboratory management with the public workflow of making whichever parts of that accessible that the researcher is ready to do. And a key part of all of that is that OSF tries to enable researchers to be able to use the services that they use, right? To open and prevent lock-in to particular service or particular life cycles with a common API connecting services around the research life cycle that they use. So we use GitHub a lot for our code, we have Dropbox for our real-time data management, and we might use Figshare for our long-term archival data store. Well, all of those are connected with the OSF, so as soon as one of those is connected to the OSF, it's also connected to all of the other services in the ecosystem. And if I decide that, I'm moving from Figshare, I want to move over to Dryad, then I have an easy means of adding a Dryad component into the service rather than staying with Figshare or Zenodo or whatever. So these are ones that are already integrated or are in progress of being integrated with the OSF now. So the goal with that is to make sure that researchers have the flexibility and choice to use the services that are most useful to them at whatever stage of the life cycle they are, and to facilitate, make it easier for them to get around the research life cycle, to get around faster so that their analytics service is linked to their data storage service, is linked to their authoring or reporting services. The other key element of the OSF is its layering to try to enable communities to activate themselves, to manage and govern their own scholarly communication services. So what the OSF really ultimately is a base level of services such as file management, security, authentication, rendering, workflow management, an ecosystem of all of these different services connected together, and then the underlying data. That is an independent layer from the interfaces. How is it that you engage with that service? So the OSF.io that I mentioned at the front end, the project management, is one interface to that underlying set of technologies. And anyone, because it's all open source, can build a different kind of interface for solving a particular problem against that underlying set. So, and then once one creates an interface, our approach is to try to make those brandable so that any group can then create a version of that interface that is what they use, how they govern, that they govern and manage within their research community. So to give you an example, I'll highlight OSF Preprints. OSF Preprints is a simple interface to try to make preprints more discoverable wherever it is that they are stored. And so when you go to the osf.io/preprints website, you can search for preprints there. You can deposit, submit new preprints, but the search really is the key because it aggregates across all of the preprint services that are connected to the OSF via our other service, Share. So if it's on archive or bioarchive or engineering archive or law archive or PeerJ, this single interface helps to facilitate discovery of those and then take you to wherever the service is that hosts that particular service. But the key with OSF Preprints is that it's brandable so that any community that wants to launch their own preprint service can get a version with just simple branding, and then they take over the governance of that particular branded version. And so we have now, I think it's up to 18 different preprint service communities that have either launched or are preparing to launch their own preprint services. And ECS Archive, EJ mentioned, is going to be one of the newest ones coming soon. So the goal of these types of interfaces is to empower research communities to be able to do scholarly communication themselves. You have a new vision for how it is you want to manage preprints and provide post-publication peer review and commenting. Great. Launch your own variation of this service and operate that in your community. right? So if we can give researchers and societies and other communities the ability, lower the barrier to allow them to start different services of communication themselves, then we can promote innovation that doesn't depend on closed or lock-in based systems for research communities to retain ownership and promote openness of the work that they do. So let me close in just noting that the challenges for shifting the entire research community to open are difficult because science is entirely decentralized. We don't get to say to one person, just say we need to all be open and we'll do it. Each society, each institution, each publisher, each stakeholder in the scientific process has their own policies, their own approach, their own ways of thinking about this. So it becomes a coordination problem because each individual researcher has an idiosyncratic set of journals, of societies, of institutions, of funders that influence their own behavior. And so in order to actually effectively move to make the open the default, we have to coordinate across a variety of different stakeholders. And so it's really groups like ECS that are at the leading edge of saying this is how we can do a Free the Science campaign, this is how we can live the mission of our organization, are key for having that not just inspire change within that research community, within the society and its activities, but also make it easy to inspire other societies and groups to do the same. So thanks very much for the invitation to be part of this. I appreciate it.